Assalamualaikum and greetings to Madam Ini and to everyone who's watching this video. In this video, me and my groupmates are going to be presenting about one of the applications of differentiation, which is related rates. Before we get into it, my name is Muhammad Hadasdin bin Muhammad Shamsul Badri, and my two other group members are Nurul Natasha binti Muhammad Sa'ad and Nur Arifah Syahirah binti Samit. So what is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. There are three techniques to solve differentiation problems, which are the derivative of sum and difference, derivative of a product function, which is the product rule, and also derivative of rational functions, which is the quotient rule. Other than related rates, there are 6 other subtopics under the applications of differentiations, which are the first one, intervals of increasing, decreasing, and concavity. The second one, first and second derivative tests, and then graphs of polynomial functions, maximum and minimum values of a function, and applied maximum and minimum problems, and lastly, rows and mean value theorem. Now, what is related rates? Related rate problems involve finding a rate at which quantity changes by relating that quantity to other quantities whose rates of change are known. So the rate of change is usually with respect to time. Differentiation with respect to time or one of the other variables requires application of the chain rule, since most problems involve several variables. So we're moving on to the steps of solving related rates problems. So we have 4 steps in order to solve related rates problems, which the first step is we have to identify the rates of change that are known and the rate of change that is to be found. So the second step, we find an equation that relates the variables whose rates of change were identified in step 1. And then the third step is to differentiate both sides of the equation obtained in step 2 with respect to time, and after completing step 3, substitute all known values for the rates of change and the variables, and then solve for the unknown rate of change.
Hi, Assalamualaikum. My name is Nurul Natasha binti Muhammad Sa'ad, and my student ID is 2021127077. So, to continue this video, I will explain and present about problem statement and problem solution. First, we will go through the question. The question states that an airplane flying at 450 km per hour at a constant altitude of 5 km is approaching a camera mounted on the ground. Let theta be the angle of elevation above the ground at which the camera is pointed. When theta is equals to pi over 3, how fast does the camera have to rotate in order to keep the plane in view?
From the question, we got around 4 information. For the first one is the altitude. The altitude means the distance between the aeroplane and the ground. So let's say this is the aeroplane, and the height is the distance between the aeroplane and the ground is equals to 5 kilometers. Alright, then it states that the camera is located on the ground. Let's say the camera is located here. The airplane is going down to approach the camera. So this is the distance. And now we got a triangle. It states that the theta is equals to pi over 3. And this distance we label as x. And the question states that this distance is equals to 450 kilometers per hour. Alright, this theta in radian, which is pi over 3 radian. So what we need to do is we need to change radian to degree. How to change? Alright, pi over 3 radian times 180 over pi and equals to 60 degree. We have to find the value of x. Tangent is equals to opposite over adjacent. Tan theta, the opposite, is 5 km and the adjacent is x. So now this is the equation that we got. Alright, we want to find the value of x. So we need to exchange the position. Substitute with 60 degree, which is x equals to 5 over tan 60 degree. Like we already know, tan 60 is equals to square root 3. So we just need to substitute tan 60 into square root 3. Alright, for this value, the airplane is going down to approach the camera. So the value will become negative 450 km per hour. So now we will continue with problem solution. Alright, firstly, we just need to copy the equation that we got just now. And now we want to raise the x up. So it will become 5x the power of negative 1. Now we want to differentiate tan theta. Alright, when we differentiate it, we will get 1 over cos the power of 2 theta d theta dt. And when we differentiate this value, we will get negative 5x the power of negative 2 dx dt. We already know that cos 60 is equals to 1 over 2. So we just need to substitute the value into the cos theta. Do not forget the power of 2. And then x, we substitute with the value that we got, which is 5 over square root 3. And the dx dt that we just got just now is negative 450. Alright, after we calculate the value, we will get like this. For this step, you just need to calculate the value using your calculator. To find the value of d theta dt, you just need to divide 270 over 4 and you will get the final answer. And the answer is 135 over 2 radian per hour.
That's all from me for problem statement and problem solution. We will continue this video with the next presenter. Thank you.
Assalamualaikum and hi. My name is Nur Arifah Shahira binti Samit and my student ID is 2021 127 and 173. And right now I'm going to continue from Natasha previous slide, which is for the conclusion and also for the reference. Okay, so for the conclusion, the solution that we use to find the value of related rates are actually successful. And for the second conclusion, we use the application of differentiation to compute the rate of change. Third, we also can accurately count the difference in changes that happen by applying the chain rule method or implicit method to solve the equation. And last but not least, we must have a high understanding of or on what is related rates and may use it to solve any problem in the future. Okay, so that's all from us, from group 2, and wish you have a good day, and thank you.